The blacksmith is marking the centre point of this block of steel. This is done before it's heated up for forging. Blacksmiths have become very skilled at assessing the temperature of the steel just by looking at its colour. The centre point that was previously marked is now being expanded to form a hole. This will eventually be where the shaft of the hammer is inserted. You can see that the block of steel is already starting to cool and become stiff. The blacksmith will keep an eye on this, and when the metal is too hard and cold to work, he will put it back in the fire to be reheated. Careful control of temperature is critical. If the metal block becomes too hot, the grain boundaries may melt and the metal will simply fall to pieces. If the block of metal is too cool, the blacksmith does not have sufficient time to work the metal before it needs putting back into the forge fire. The metal is again getting cold. You can see this from the cherry red colour. The blacksmith is now having trouble deforming the metal by striking it with the hammer, and the block of metal will need returning to the forge fire. The blacksmith is now using the hammer to forge the steel block. This is a very fast and efficient way of deforming the metal. A lot of work can be performed on the steel block before it has to be returned to the forge fire.
Right, I think that will do.
Forging of a ring, so you calculate the weight of your billet you require plus 5% because you lose about 5% in your furnace or your fire. So then you calculate your weight and then you cut your billet off. Then it's into the furnace and get it up to temperature. You take it out of the furnace under the hammer and you get your billet and flatten it down. And then you get your punch and you punch it from both sides and round it up on punch till you get a nice square clean hole so it's all in line. Well, these rings were in the N8 and they took them up to about 1200 degrees, and there's usually enough heat in them to get right through the operation, but if you've any delays with things going wrong, if it drops below the temperature, you know, down to about cherry red, we're back in furnace and reheat up again. But usually you can get it right through in one operation and button drift it and on the floor finish. We just forged an eye bolt in wrought iron. We use wrought iron for that. What you basically do is we made a foot eye bolt on one end and drew it down. Then we left a thicker section at the end and we put what we call a scarf on it. An handled section, scarf down and thin down. It's the reduction of drawing down. The more you draw it down, the finer grain you get. So you get a stronger material. You know, it hammers the grain, fine grain. Hammers it all in, like consolidates it all. Gets it nice and compact. And then you get them up to a welding temperature in the coke forge till they're nice and pasty and melting. Then you bring them out quick under the hammer, lay one on top of the other and hammer it in and it fuses it together. And then you just hammer it down to a peg till you get to the right and then swage it. And if you're lucky, it's a good solid weld that. From a shaft, if we knock it down, the grain follows the line of the shaft. Not like when you're machining. If you machine into it, you cut into the grain, but by forging it, the grain follows the shape you put into it, so it gives its added strength.
This steel bloom weighs over 150 tons and has been heated and soaked at a temperature of approximately 1250 degrees centigrade. The importance of temperature control cannot be overemphasized. Too high a temperature may result in melting of grain boundaries in the bloom. Too low a temperature may result in cracking or bursting of the bloom during forging. In order to form a ring shape, the bloom is being punched. This could not be done cold, for example by drilling, because the hole required is very large and it would be uneconomic to cool the bloom and reheat it. The ring is now being further forged into a cylinder shape. Curved tools are being used to help form the outside of the cylinder. The intense pressure and high temperature cause the metal crystals to first elongate and then recrystallize to a smaller grain size as forging progresses. These grains are squashed and elongated in the direction of working. This can be controlled by careful attention to the chemical composition of the steel, the temperature, and the extent of squeezing. A smaller grain size promotes a stronger, tougher finished product. The cylinder is now near the final stages of forging. The inside of the metal forging remains relatively hot. However, as the outside cools, it becomes progressively stiffer until it is too cold to forge easily. The bloom may require reheating and forging 4, 5, or 6 times before the final shape is achieved.